Hello, my name is John Kruja, and this is my final project presentation for the Big Data Analytics course in Harvard Extension School given by Zoran Djordjevic. My topic is Redis, which I call the Golden Speedster. We start off with a problem statement. Let us assume that there's a fictive non-profitable organization that makes an analysis from Wikipedia data among different countries. They look at the page hits per month, and their solution is devised as a traditional Kimball data warehouse where there's a staging database which extracts the data from the feeds from Wikipedia and which are data export files, and then they're submitted into normalized data warehouse and data marts where there are fact tables and dimensions, and they're aggregated on daily basis by country and topics. And then as an acceleration layer, there's an OLAP cube for ad hoc analysis and some reports. And the users are currently happy about the performance and the analysis options. But one day comes our boss, breathless, running from a stakeholders meeting and says that they need to build a new analysis platform or extend the new existing one with in order to track user page hits and make the analysis on users levels and look at the data that is frequently visited. And this imposes a quite challenge for Johan, the business intelligence chef, which knows that the data goes through a certain pipeline and maintaining real-time performance is kind of a challenge because raw file Wikipedia is updated from as an append-only file on a monthly basis. So they have to read the same file over and over again, staging, and do insert update on the normalized data warehouse, and make some transformations of the dimensions and fact tables in data mart, and then load the data to the cube, and then the users have access to the information. And also there is a performance drawback with listing top users. These questions are neither are ideal for databases, relational databases. You can build lots of indexes, but then you have a trade-off with the inserts, ETL transformations. So what it does is to look around on the internet in the upcoming 2 days, read about Redis, and this invention seems to him as the best thing since the invention of sliced bread. And that kind of gives him a good gut feeling and says that, okay, he's going to engage in this conversation with his boss and convince him that they could use Redis for the new set of goals that emerged in the last meeting. Here comes their conversation the day after that. Hello, Johan. Have you found a solution for our challenge? Yes, sir. I have a technology proposal, and this tool is called Redis. It's an in-memory data structure server, which you can classify as NoSQL if you want to classify it. You mean relational database? I call it data structure server because it supports the data structures that we study in university, like hashes and lists, rather than thinking about tables. And it's the interesting aspect of this tool is that it gives blazing fast lookup speeds, most often in O1, order of O1, when you have a hash lookup or key lookup. And the performance degrades when the structures get and information model gets more complicated, but still it performs much faster than the relational databases. Now that you mentioned NoSQL, so I heard of alternatives like MongoDB and Memcached. Why aren't we using these? First of all, Memcache has no persistence, so I believe that it doesn't belong to this scenario because in case of failure, we're going to lose data and it doesn't cache data to disk. Secondly, MongoDB uses only disk, it has persistence, but doesn't give the same performance levels. Thirdly, we have is data structures, as I said, the data structure server. So it has simple but effective structures like sorted sets where we can track our KPIs. And what's our KPI? User counts, page counts, and we can sort it, have scores for users and have a list in microseconds, something we couldn't do with the relational database. And we have hyperlog logs and different structures that we can build unique counts. Most companies use this unique counts for basket case analysis or web log analysis where a certain user has been online or offline. But you keep coming back to the memory stuff. I fear that if this tool that uses lots that's reliably based on memory eats up all the memory, crashing itself and then crashing other applications, wouldn't be a catastrophe. Yes, but we can avoid such a scenario by, first of all, setting a hard memory limit in this configuration file. Whenever it gets over this limit, it will start releasing memory by releasing some last non-used keys. We can change the actual algorithm LRU or random key release, or you can set expiration date to the keys. So it will release memory after reaching that threshold. And other than that, there are compression methods that emerged by Redis team, Zipless, which took the attention of different companies like Pinterest or Twitter, where they switched their solution from Memcache to Redis. And another important aspect is that whenever a node runs out of memory, before a node runs out of memory, we can avoid it by sharding, which is a form of horizontal partitioning. So we partition hash maps across different nodes. This is a good feature, but let us say that one of the nodes crash. What happened? If it crashes, we lose consistency and persistence. Yes, but we can avoid it by setting up slave nodes that asynchronously change data with the master node. And if a master node doesn't respond after a certain threshold, which is set by the node timeout parameter in Redis configuration, the slaves can choose a new master, and we can do it on the fly. We don't need to set up the server, but we can add multiple slaves and add different topographies, which is kind of an important aspect. We can make more slave nodes to cover those situations. So far, so good. But which platform are we going to run this on? I think we should use a Linux machine because Windows installation is partially supported. You can set up on your computer. I did it initially, but then Linux version is supported by the development team, and there are lots of updates, and you can do advanced cluster setup analysis. And then we could always go to the cloud and use Amazon Elasticache for Redis. And almost a month ago, Azure released their Redis cache, Microsoft's cloud solution. So I think more and more companies will utilize this platform, and we can use the cloud options as an alternative. Is there a risk for learning new codes and protocols? Not really. It has the set of clients for all the programming languages. And today, before I came to work, I figured out that R was also one of the options, although it's not listed in here in the page that I compiled. And the client protocol is quite simplified, and its taxonomy is so intuitive. For instance, set get, it applies to key value pairs, and then hset hget, it applies to hash values, and then z prefix is related to sorted lists. So from the prefixes, you can guess which functions apply to which objects. So another remarks before we start this journey. Yes, one last thing is that the publish subscribe pattern, which I intend to use as a building block from the Wikipedia feeds. And we can also do lots of event-driven triggers and establish inter-application communication, which means that a client that runs on Python and another client that runs Java can easily communicate through this bus channel that's provided by Redis platform, and it takes only 2 lines or 3 lines of code to implement this feature. And I have the feeling that we might gradually change our commercial message processing bus to Redis and use this both performance and simplicity. Interesting. So please show me what you got. Here I start the Spark application. That extract the files. It will take a while. On the right corner I have my user cacher Python that's listening to the channel actively. Here I have my Redis server that says that I have 2 clients connected. Here I have my R code. I'm gonna come back to it later. As we see, the data processing logic has started. It's verified that the HDFS file exists, and it's verified that the HDFS output file doesn't exist. If it exists, it will remove it. Start with the MapReduce job. It hasn't created the RDD yet, otherwise we would hear some messages on the client on the right hand side that's using the Python code. And the Java code will come into stage also soon. Since I have lots of panels open, I shall come back to this screen in a short while. It's almost complete. In the original version, before the demo, I was running MapReduce in Yarn mode, and I switched to Spark because it felt much faster. Still no action, which means that it hasn't come to the RDD stage, but should be a few seconds after we see the RDD red message, when everything will start pushing data. And as you see, you have the historical name diagram counter, because I had worked on the old source code from my previous assignments as the underlying foundation. And here, something's happening. Our publish subscribe channel got some files, and it hopefully saved it to our database. And Redis is saving the data here. Good. Now I would like to run my Java code. And it asks me how many users I would like to see. Let us say 30, top 30 users. I accidentally forgot to delete the whole text. And the server is running. And it says that it's displaying top 30 users of 30,575 users that have data. So it's a typical leaderboard application where we see the data. One last thing for the demo is that we could use R to display our results. Here's this. I would like to retrieve, let's say, 15 results. I'm using R Redis library for my R interface. And what I'm going to do is get a leader list from this channel, not channel, sorry, the key called user score list, which was read by Java as well. And in the decreasing order with the scores. If I write leader list, it won't say anything because it's case sensitive, and I forgot the L. We get lots of scores here. Well, I would like to make a bar plot out of it. And voila. Here you see the top users with the ugly legend over the top. But this demo shows that we can use at least three clients to access data and modify data.